Our standard machine is about 4 by 4 meters. Just think about how much volume a container like this uses versus a single blank.
Yeah.
So you can have, I don't know how many more in the warehouse. Currently we are offering the CBU unit, which is our standard machine unit for cups and cans, up to 160 containers a minute.
Okay.
We newly introduced our MCM model, which is up to 200 containers a minute, up to 300 millimeters in height and 185 millimeters in diameter.
Okay.
Very easy changeover. And this is made for not gas-tight solutions.
Okay.
So if we move on to the gas-tight solutions, we have our Paper One. So the Paper One machine is created to produce gas-tight solutions up to 150 containers a minute.
Wow, so that's really fast. Welcome to the home of fiber. Today I have a guest. It's Michael Wagner. Michael is site manager of Weyhmüller. Welcome, Michael, to this episode of the podcast Home of Fiber.
Good morning, Dominik.
So we will talk today about the topic of paperboard forming. So Michael, who is Weyhmüller?
Weyhmüller is a machine producer in the heart of Bavaria. It has been founded 80 years ago. Our key products are paper packaging machineries, especially for isodesto cups, for cone winding, for paper cans, especially. And we are having like roughly 3,000 machines in the market. Our employee base is about 40 employees. And since 2023, we are a full member of the Optima Group.
Okay. When was the company founded?
1946.
1946. So already a long heritage in knowledge of paperboard forming.
Yes.
That's great. So what kind of products can we pack in paperboard? Could you give a few examples?
Well, you can technically pack many products. Our key competency is dairy, food, non-food, consumer goods. All those are used today already, and we are expanding our portfolio almost on a daily basis.
So in the end, it's the whole consumer packaged goods industry, means food, non-food.
Yeah, that's correct. Yes.
All right, very good. So if we talk about the different packaging solutions coming from the product, what kind of packaging can we produce with paperboard forming?
Well, we can produce the standard isodesto cups, as many people know already, especially from the yogurt or dairy industry. Besides that, we can produce paper cans, parallel walled containers.
Okay.
And with those, we are expanding our portfolio, as mentioned, into new markets. So we are planning to replace, or the market is planning to replace, multiple components made out of plastic, aluminum, tin metal, whatever, with paper.
Okay. So you talked about Weyhmüller is part of the Optima Group since 2023. What makes this merger so special, and which key competence brings Optima also into that field?
Our key competence is the paperboard forming in combination with having them ready, having them separated, having them packed, stacked. Now Optima is coming into the play, and with their key competencies of filling, sealing, ultrasonic technology, that actually rounds off the entire picture and leaves us with a one-stop shop opportunity for the customer.
So I think we talked already about a really important unique selling point. You mentioned ultrasonic sealing of products. So if we talk about paperboard and all what's happening with the regulation with PPWR, ultrasonic enables that we use PPWR ready materials. So we talk about really thin coatings, so a fiber to coating ratio of 95 to 5. And we talk about gas-tight solutions, so high barrier packaging, where we are able to go into applications like baby milk powder or coffee. Yeah, so high oxygen, high water vapor barriers, where we really need a tight sealing. So that brings me to my next question. How can we support the customer with our technologies for PPWR?
Well, our machines are planned to be or already ready for the PPWR regulations. That means our ultimate goal, or our goal, is to be in the 95.5 range to achieve the Class A for the PPWR. With knowing this, you need new materials. With the new materials, you need new sealing technologies. So now ultrasonic comes into play together with our standard machine portfolio. And the combination of that actually does the job in the end.
So when you talk about new materials, I assume you're talking also about aluminium-free packaging, because that's also a wish from our customers to have aluminium-free high barrier packaging. So sealing technologies like induction are not possible anymore. Yeah.
That's correct. That's correct. Yes.
Okay. If we talk about those gas-tight solutions, could we talk a bit about levels, what we can achieve, means in oxygen transmission rates and water vapor transmission rates?
Well, on both of those key measures, we are below 0.1.
Okay.
Which is, I would say, outstanding for the paper-based solution.
Yeah, that's absolutely high barrier packaging.
Right.
Yeah.
So if you use something out of plastic and 7 layers and you can achieve that. But that we can achieve that now with a super thin layer of barrier combined with paperboard, that's really outstanding.
Okay.
And that's really unique.
So could we talk a bit about those materials where we were able to reach those high OTR and WVTR values?
The material we are currently using has a fiber rate of 97%. And it's completely aluminum free, which really brings us to the next level of what we have to achieve.
Okay. That means this brings our customer all benefits for EPR fees. Yeah. And it's important to highlight again that worldwide, the paper recycling stream is the best working recycling stream in the world. Yeah.
Yes.
So let's talk a bit about the process to produce all those different products.
Well, we mainly start with a blank.
Okay.
So we use the blank, we separate the blank, we bring the blank into the machine, we put it onto a mandrel, and with 2 folding wings, we are closing the mandrel, the blank itself, and then we have a container. The container can be sealed by standard sealing today with heat for a PP layer, for example. We can use hot melt application. We can use cold melt. We can as well use ultrasonic as needed. Then the blank moves around on a circulating table to the station where the bottom is applied. We either have a pre-cut bottom station, so we are introducing lids into the machine, or we cut out bottom discs of
So this would be a real feeding solution, and
correct.
Then we cut
Yes.
out in line. Okay.
Yes. So we would have a reel, cut them out, and bring them into the machine. Then we do like a forming of the standard bottom itself. We push it in, we roll it around, we press it tight, and then we move the material forward. Do we have to have a check with a camera? Yes, no. Do we have to have a single recheck? Yes, no. And then it's actually released onto the buffer table. And then it's up to the customer how they want to proceed nowadays. That's for the parallel walled containers. For the isodesto solution for the dairy market, it's pretty similar, but we're having this thin plastic inlay, which will be put onto the mandrel first, off a stack, separated onto the mandrel.
Okay.
Then the mandrel moves in position again, and then the blank, as before, moves onto the mandrel, will be closed with the folding wings, and then it's sealed off.
Okay.
Nowadays, it's really important for our customers that we use self-separating material. That means the plastic inlay holds the blank itself with a special rim on the bottom area.
So there's no extra glue between
No
the
extra
material.
glue dot that leaves the inlay clean, so it can be better recycled, and then it will separate by pressing onto the cup itself.
Okay.
So that pops open the technology they're using. There are multiple technologies in the market. Everybody does it a little different. But in the end, it's about how does the paper separates from the plastic.
So there's no need that a customer actually separates the material. It will happen during the recycling process, because we all know it's hard to educate the consumer to do that.
Correct. The percentage of people really peeling it off is still really low. And with these new technologies and patents, all those customers are using, we are doing the next step.
Yeah. Okay. So you mentioned Desto ISO. Could you explain the difference between those two packaging solutions?
Yes. A typical ISO cup, as here, is a plastic inlay and a paper wraparound.
Okay.
There is no bottom. The bottom itself is the plastic itself. For a Desto version, we do have a paper bottom as well. So the plastic sits into this paper container and it's fixed in it. Is Desto the ultimate future solution? Questionable, but that's really up to the market. There's certainly some applications where it will be the to-go opportunity.
Yes.
But I think mainly ISO will be what we will see in the market later.
Okay. And you showed also different designs. So not only a round solution, also a oval solution is possible.
Correct. We can handle round or non-round. Non-round can be from a wide oval shape into a little tighter oval shape. Technically, square, triangular, all those shapes are
really flexible.
Possible. Yes, we are really flexible, and that separates us a little from other machine suppliers as well.
Okay, interesting. So we have also customers, they don't want two components in their packaging solution. What do we offer in terms of pure paperboard cups?
So we have an sample here.
Yeah.
Thanks for giving me that. So this is pure paper. It is basically the same technology. You do the wraparound, you have the bottom in, you have to seal it tight, and then you have to have a proper rim. In this specific case, it's a flat rim, which helps us a lot to seal tight.
Okay.
And therefore creating the barrier to the outside.
Yeah. So we have a bigger sealing surface.
Correct.
Okay.
Yeah. Our standard rim is rolled, so therefore it's round. And if this is efficient enough, we leave it like that. If there is more needed, more sealing surface needed, we go for the flat rim that can be pressed and then we can use this.
So would this solution be also gas tight possible?
At a later stage, yes.
Yeah.
And that is what we are working on, especially together with Optima we're working on. Here we need the prep of the material, we need the ultrasonic sealing, we need the closing of the bottom areas and so on and so on. But the ultimate solution is a gas-tight paper-only seal container.
So coming from standard drinking cups and ice cream packaging with some polyethylene coating to be able to be sealable, we move now to high barrier materials, also PPWR ready, and then through ultrasonic sealing we are able to manage it gas tight.
Correct.
So markets like the snack market, which are growing actually, we could target also with that solution. Yeah.
Yes.
Okay, perfect. So let's move to the topic of parallel walled containers, means cans in the end. We have a lot of solutions here on the table. Maybe let's start with those cans next to you.
Okay, then let's start with this one. It's a typical detergent packaging, you see like a little perf line here, and you can open the container like this, which leaves you with a double-walled container on the inside and a dosing cup that can be used to dose the product, feed it into the washing machine or wherever.
Yeah.
So that is a solution we are offering.
So how do you manage the double wall concept?
Well, as you see here, the plank itself already has the double wall in it.
Okay.
So we feed the plank, there's a little extra to it, and then we roll it around and we seal it on the side, and therefore we have a container with a double plank.
So in the end, we use here the lid to dose the product, which is great because you don't need any additional spoons or scoops.
Yes, correct.
So we have more fiber in the overall packaging.
Yeah, you get rid of everything unnecessary.
Yeah.
And you have the feeding, the dosing concept already within the packaging itself.
Reclosing is also possible, like you showed.
As we see here.
Perfect. So maybe let's move to the topic of snap-on lids.
So snap-on lids, we're having like a standard roll, as we said, what we can do. Here we see a round roll sealed off with a membrane. And then you have a snap-on lid, which is a paper-based lid. And that can be, as a plastic one was before, being snapped on and being peeled off again.
Yeah. So this would be an external supplied lid.
Yes.
What we feed to the machine after we fill the product, seal the membrane to the packaging, and then it's external feeded.
Correct. And then it will be fed and placed and the sealing.
So you showed a membrane which is sealed on top of the mouth roll. Are there also other possibilities to seal a membrane into the packaging? I mean, the membrane brings a barrier, product protection, and B, also temper evidence.
Correct. So we can have a couple solutions. One is as I said, the round rim. You seal it off, and you have a relatively small sealing area. Then you have the pressed flat rim, so to say.
You showed with
like
the cup.
here, So the sealing area is much bigger, and sealing is much better. And then you can also introduce a membrane within the package itself.
Okay.
So you lower it in the product.
It's like this one, huh?
Yeah. So
okay,
it's lowered into the product, and you still have the open-close functionality of a plug-in plug then.
Yeah.
Paper made, and it especially works here as a temper evident solution as well, because when you open it up, you see exactly, hey, was it pre-opened or is it still in the original condition?
Okay, maybe let's stay with that container. I mean, we have different solutions here. What are the advantages compared to such a snap-on lid? I mean, that's what we call a plug-in lid, right?
So all this can be done in line. 100%. There's no need of buying material from somebody else.
Yeah.
So the entire process is an inline process. And that's the key advantage of that. You don't have to ship material around. You don't have to have a buffer here. You don't need a bigger warehouse for different preformed materials and all that.
Okay. I mean, what I also see, it's we don't have that mushroom effect of the snap-on lid. Means we can transport them more close,
right?
And it's a clean design, right? So reclosing is also possible. It's also a great solution. Okay. Sometimes customers don't want lids which are separated from the packaging. So here we talk about consumer experience, especially in markets like baby milk powder, where it's really difficult to handle on one side a baby, on the other side open the packaging, mix it and do the job for the baby milk bottle. What kind of possibilities do we have to attach a lid to the packaging and make the whole handling for the consumer easier?
Well, the best solution, but that's my personal opinion, is a hinged lid. So as you have seen with the curved line, and let's talk about a square container.
Yeah.
You just, as you
brought this one.
have here, yeah, correct. So what can we do? We have a perfect line around, but in this specific area, we are not cutting completely through, and therefore we do create a hinge. It can be open and closed.
Okay.
So it stays with the container.
Yeah.
Here again, a lowered membrane within the product.
Yeah.
And that makes it much easier to keep the lid with the container versus now it's falling down and we have to worry about that.
Yeah. So we don't have the mushroom effect. We have the lid attached to the container. What else do we have? We have temper evidence because of the perforation. So in connection with the membrane itself, we have 2 type of temper evidence solutions here. Okay, great solution. Is that only possible for square design or rectangular design, or
no? It can be done for round design as well.
Round design also, like this one, what you brought with you. Okay, really good.
So same solution, just different shape.
Okay. Sometimes we have customers, they don't want a fiber-based lid. They want to have different materials. Very often marketing reasons for that. What kind of possibilities do we have for that?
Well, as we have seen here, it's the paper itself, which some customers really do not like too much. Then we can use a plastic snap-on or a plastic plug-in, as we see here.
Okay.
Same thing, made out of plastic, same functionality. Or we can use metal for some products.
You brought also one.
Over there. Yeah. So this is a plug-in metal lid.
Okay.
It can be as well be a snap-on metal lid.
Yeah.
That's really depending on what the customer wants. But also those can be certainly be used on our lines.
Okay. Oh, that's cool. So we started with that dosing function for the laundry detergent, where we use the lid to dose the product. Maybe let's go to the food area, and we talk about, I don't know, baking pearls, for example. Do we have other solutions to dose products, maybe as a spreader solution?
Yes, we do. I mean, as everybody knows, salt, for example, or baking pearls, as you said.
Yeah.
So you have like this sliding lid, so you can open close, or you can rotate to have a different dosing method. That's all possible within the machines as well.
Yeah. Which is very often plastic today, sealed or glued to the packaging, which makes it, of course, complicated for PPWR. So maybe you can show our fiber-based solution to dose such products?
Yes, of course. So on this specific one, we're having like a plastic plug-in, combined with a dosing solution, all made of paper. So as you know from salt and other dosable products, you just rotate it depending on how much.
We show fish fat actually, also possible for that.
Example, it's not necessarily human food only.
Yeah,
it can be basically everything you have to dose in a certain way.
Okay. So you rotate it and you have different opening sizes.
Correct. As we all know from
dose perfect. Yeah.
Salt. I think salt is the best example, so that that all the listeners know what we are talking about.
And I've seen another solution you brought with you, that orange can.
Yes. It's a different solution with a tear-off strip, which is removed already, and after removing it, you just open the can a little and you have a dosing opening. Now you can pour out the ingredient and close it afterwards. So you have like a open-close solution, easy to handle, easy to put on the shelf again.
So it's a lid which is also inline produced with our closing technology, and you're still able to dose the product.
Correct.
Yeah, great. Okay. And I've seen one last one. Here it's baking pearls, chocolate baking pearls. So maybe also a short explanation of the solution.
Okay, paper snap-on, as we have seen now multiple times. And then the lid/membrane itself has the dosing already, the dosing cutouts.
Yeah.
And so you have almost like a tamper-evident solution. So you open it up, you see, okay, it was not used before.
Yeah.
Then you peel it open, and you can dose as much as you have to have onto your product or.
Okay. So maybe let's move to our specialty solutions, what we have in the group, and start with that can for burger sauce, which is really special because it's different to all of the other cans. Yeah.
So this is a parallel walled container as the others as well. It has a plug on the back, and it will be used in like a kind of silicone gun tool to dispense on the burger itself. So the trick here, the bottom part is made out of two components. It's the paper, which is folded in, rolled in, and pressed in.
Okay.
And then you have this plastic material, which has dedicated openings so that the right amount of sauce is dispensed onto the right area, so that every single burger experience is exactly the same.
Yeah. And I learned the bottom is not sealed well to be able to break free in the so-called sauce gun or whatever. It's like a silicone gun, what everybody or most of the people know. And then you are able to push out the sauce.
Correct. You just seal it on barely, and by the first touch of the gun itself, it starts to move downwards and pressing out the sauce itself.
Okay, that's nice. So and then I've seen some really special solutions like that hand soap. I think there's one without that gun. So maybe a few words about that packaging solution.
Yeah, as you see, there's the not used one with the lid on top of it. Correct.
Also membrane. Okay.
Yeah. So you peel that off, and then you screw on the dispenser unit. Here, stainless steel. And then you pump it out as you know of all the liquid hand soaps.
Okay. So you buy once that pump, and our packaging would be the refill.
Correct. Typical refill solution. Yeah.
That's great. And I know also that packaging solution.
Yeah, especially the kids know that.
So maybe a few words about.
Same thing. It's the standard Calippo, what we call it. It can be used for, of course, ice cream, as most of us know it of. But it can also be used for any other ingredient. Like, let's say you can put in baking pearls. You can put in gel. You can put in fruit squeeze, something like that. All that can be put into this kind of packaging. And it's a fully paper-based, no more plastic, where we have to be.
Okay. So we talk about single-serve packaging, right?
Yes.
Yeah. Okay. Oh, that's nice. So we have seen a lot of different cans and cups with different designs and liddings. Do we have some other design options which makes our technology special compared to other technologies in the market?
Well, we can have it, as I said before, you can have it not round, you can have it triangular, you can have it squared, you can have it almost in any kind of shape the customer is requesting us to produce. Our machines are made for being easy changeover machines. So within 25 to 40 minutes, a new product is on the machine, and the machine can go back into business.
Yeah. Okay. I've seen one special solution with a view window you brought with you. I think that's this one.
Yeah. And that's the big difference for a plank machine versus a spiral winding machine.
Okay.
So we can produce a container like this with a see-through window. So you see the goods in the container. You see the fill level within the container. It can be in all different shapes. It can be bigger, smaller. All that can be done.
Yeah.
We can as well use like a metallic surface to make it look really high value. You can have embossing to it. You can have debossing to it.
Yeah.
So the plank itself has to be prepped in the way the customer wants it.
Yeah.
And then we can use it on our machines.
Okay. So you mentioned machines. We talked about all those different packaging solutions. Let's move to the topic of the machines. What kind of portfolio and range do we offer to the market?
Currently, we are offering the CBU unit, which is our standard machine unit for cups and cans, up to 160 containers a minute.
Okay.
We newly introduced our MCM model, which is up to 200 containers a minute, up to 300 millimeters in height and 185 millimeters in diameter.
Okay.
Very easy changeover. And this is made for not gas-tight solutions.
Okay.
So if we move on to the gas-tight solutions, we have our Paper One. So the Paper One machine is created to produce gas-tight solutions up to 150 containers a minute.
Wow, so that's really fast. How about the closing of those canisters?
Yeah. For this, we have the Paper One closing machine. It can compete with the exact same speed and closes in a way you see here on the table. So we can handle all those solutions in a gas-tight version.
So it seems we have some really breakthrough solutions for the market. Let's talk a bit more about the USPs of our machines.
For me, the key USP is the flexibility of our machines and the changeover time of our machines, the chance to handle round, non-round products, different heights of material. And now with the Paper One especially, we do have gas-tight, non-gas tight. We can use with plastic inlays. We can remove the plastic inlay completely. So we are having such a wide range of opportunities now that we are really standing out of the rest of the machine builders.
So compared to the business of where I buy already erected cans, for example, a spiral winded can, you mentioned the fast size changeover. So when I want to change the design of my packaging or the size of my packaging, I don't have to wait for new products being produced from a supplier and shipped to my factory. So I can change really fast my own machine. How about the size of those machines?
Our standard machine is about 4 by 4 meters, so which is really compact. But to what you said before, just think about how much volume a container like this uses versus a single blank.
Yeah.
So you can have, I don't know how many more in the warehouse versus, like, as you also said, they have to be produced, they have to be shipped. So you have to pay for shipping. The CO2 usage goes certainly up by using trucking. So all this combined by doing it all on site is a super big benefit for the customer.
So we not only talk about flexibility and better solutions for recyclability, it's also about costs.
Correct.
And CO2.
There's an immense cost saving by producing on site versus shipping it through half of the world.
Yeah, understood. So we talk about producing the canister in front of a filling machine. We have learned with the Optima Group, we are able to do turnkey projects. So let's talk a bit about our offering here and what makes us unique for our turnkey project.
So what you do is you start with a plank, and the whole journey ends on a pallet, and all this can be offered by us. So you have, as mentioned before, a one-stop shop.
Yeah.
You can come here, you get the right people on the table, open discussion, technical detailing, and then you will have a beautiful line from A to Z from one company.
Okay. Seems to be really great. So what do you recommend our customers how to start a project and approach this?
Well, reach out to us, bring your necessities, your ideas, and we will work with you. We will bring our experts to the table as well to support you with material knowledge as well as machine knowledge. So I think this rounds off the entire picture in general, since we are no longer just a machine producer. We are much more now. We are within the group the full solution provider. From what material can be used to, okay, which shipping company should I use almost.
Yeah, sure. Means we not only recommend the material, we could also go into a proof of principle, produce first samples for our customer, and then also help build a supply chain. I think it's also really important to highlight that we have an open system. So we have full material flexibility. So the customer can decide where to buy the material and which material. Because of the ultrasonic technology, we are really flexible which material is used on the machine. Also great to highlight that one.
And I think that you brought up two really, really good points. First, yes, we can do the proof of principles. If you can produce a cup that looks exactly, or a container that looks exactly like the one you will have on your machine later, that's such a big benefit, because you can hand it out to marketing, you can hand it out to all your packaging team and see, okay, does that work for us? How is it? Haptic feeling,
Do
visibility.
a consumer test, stability
all
test.
That can be done
test,
with us. And I think that's something that becomes more and more important as well.
Okay. Great, Michael. I think that was a really good discussion.
Likewise, thank you.
Thank you for joining that podcast. And for you, stay tuned for the next one. Follow us and see you next time.